Okay, before we get to our last parent function, we just have to get a little more information about what happens when I graph rational functions, which is not something you do as much in Algebra 2. It's more of a pre-calc thing, but it will help us go over soon. So first off, I already have this function in here, 1 over x plus 2. I'm going to go just to zoom 6, and we're going to draw a sketch of this graph. So we haven't seen many graphs like this, but if I draw it out, goes here, and this graph, it's going like this, and this piece of the graph is going like this. And next we're going to look in our table, and we're going to look for an error. So I look and I see I have an error at -2. And the reason is, right, you can't divide by 0, right? So if I plugged in a -2, that would be an undefined value, right, which is why we see an error at -2. What happens to the graph as we head towards -2? So I don't know if I graph this perfectly, but basically at that spot, and pretend that line's perfectly straight, we get a vertical asymptote, kind of like we do with a graph of a logarithmic graph. So as we go towards that value, the y values go towards infinity or negative infinity. So on this side, we're going towards infinity. On this side, the blue graph is going towards negative infinity, right? At that vertical asymptote, but they can't touch that line. So the reason we're doing this is because the next graph, even though we don't see it at first, is a rational function, and we're going to end up with some of these vertical asymptotes. So the next thing we're going to look at is the ratio of y to x on the unit circle. Now we know on our unit circle, I'm going to maximize this quickly, just so we can see it a little better. Zoom in a little bit so we can see this better before we start. Okay, so on the unit circle, if I want to do y over x, right, that is the tangent of the angle. So we're going to be looking at what does the graph of tangent look like. Now, sine and cosine, like pretty much almost look the same. Tangent, not at all. Okay, it's going to look completely different. So as I graph these points around the circle, remember we're doing y over x. Okay, so if I do y divided by x, 0 divided by 1 is 0. That's fine, right? My denominator is 1. But then when I come up here to pi over 2, I get 1 divided by 0, the thing we're not supposed to do. So that's undefined. At pi, I get 0 over -1, that's another 0. And then here, I'm back to -1 over 0, which is also undefined. 2 pi, back to 0 over 1, which is 0. So we really do not get a lot of information about this graph. My axes are around in the same spot, because basically I have zeros and a bunch of undefined. So it's really hard just from this basic table to see what's going on. So I'm still going to use those same scales as I did on the other page. Okay, so I have a 0. Whenever I see undefined, I have to draw one of those dotted lines because the graph can't go there. Okay, pi, undefined, 2 pi. Okay, so from here, basically I need to figure out where does the graph go, because it doesn't just stay on those points. Now we know at the dotted lines, the two rules are it could go towards positive infinity or it could go towards negative infinity, one or the other. So if I look at tangent values, and I'm going to start here, from my chart, this is the square root of 3 over 3. This is a 1. this is the square root of 3, and then this we had found out over here is undefined. Okay? So my choices are positive or negative infinity, right? So now I know my graph, because those are positive numbers, as I head towards pi over 2, has to go towards positive infinity. I'm going to write out some decimals just so we can graph those. So this is about 0.6. This is obviously a 1. And this is 1.7. So here I have a 0.6. Actually, I'll start with 1. So this is 1. In here I have a 0.6. And here I have a 1.7. So basically, and it's kind of hard to see, this graph right there has to go towards positive infinity because of the positive numbers, and at the dotted line it has to do 1, 2. So going in the other direction, we know the tangent values in the fourth quadrant are negative. So this is negative 0.6, negative 1, and negative 1.7. This is another undefined. So as I go back towards negative pi over 2, okay, and I chose this because we're going to get one of these slashes, okay? I get here, here, so we end up with this graph that's going like this. So we have another dotted line of negative pi over 2, okay? And basically, if we come over here, the same thing's going to happen. Now, this is something we're going to see we can use the calculator for, but what I like to think of is what quadrant I'm in. So between pi over 2 and pi, if I was on the unit circle, I'd be in quadrant 2, so tangent is negative there. Between pi and 3 pi over 2, that angle would be in quadrant 3, where tangent is positive. So I can also decide which infinity I go towards, depending on what the quadrant is. And this, now that we see the pattern, right, this is going to go down. We are continuing this graph out to negative pi and 3 pi. So these dotted lines keep repeating at regular intervals. So this side is going to go up and down. And over here, this side's going to go up. Okay, so we have that repeated pattern just like the other ones, but it's a totally different type of looking graph. It almost looks like a bunch of cubic functions or x-cubed graphs in a row. It doesn't have quite the same bend, but it does have that look. So what is the y-intercept of tangent? The y-intercept of tangent is 0. Right, it crosses at 0. Tangent does not have a maximum value, a minimum value, an amplitude, or a midline. And the reason is because its domain is negative infinity to infinity. So those values assume that we have a highest and lowest point to even measure those things. Maybe we could say the midline is at y equals 0, but there's nothing that's definitively in between negative infinity and infinity because they're undefined values, so we don't have a midline. Period of tangent. Basically, we're saying how long is it to do one of these slashes. So this is a little different than sine and cosine because I only have to go from negative pi over 2 to pi over 2. That's a total, like negative 90 to 90 is 180. So the period is just pi. I just switched over to degrees to make it a little easier to think about. We can see with tangent, if we rotated it 180 degrees about the origin, the tangent would fall on itself. So tangent is an odd function. And this also goes along with our negative angle identity. The tangent of a negative angle equals the negative tangent of a positive angle. And that matches up with the fact that on an odd function, f of negative x is equal to negative f of x, similar to what happens with sine.